So when we last left off, we talked about nested loops. We printed out a triangle using nested loops. I believe we talked about do loops as well. We're going to make a real short recap of those two things. So I'm just going to create a project. It's going to be a console C# project, and we're just going to make a do loop and a nested loop. Nothing too complicated. So the difference between a while loop and a do loop is that a while loop is pretest. Looks like that. X is equal to 10 while x is greater than or 0. Yeah, I'll turn the projector on so that the students in class can see this. We're going to, nope, you don't use cout in this. Console dot write line x, and I'm going to write the word for in front of it, excuse me, while, just to indicate that we're using a while loop. Can we do that? Now let's use a placeholder. Let's be totally C# style. And then we have to decrement x. So this is going to count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 with a while loop. Called a pretest. The test is a gateway into the body of the code. If this test evaluates false before we even go in here, then the code won't even execute once. The while loop is a post-test. Excuse me, the do loop, otherwise known as the do while loop. So we're going to do another one. Do some stuff while y is greater than 0. And you do have to put a semicolon here. Whereas normally if you put a semicolon on an if or a while or a for, it short circuits it. And if you do it on a while, it'll go into an infinite loop. But we have to have a semicolon here because this is treated as an entire statement right here. And we're pretty much always going to use braces there, although technically you could probably get away with leaving the braces off if you had just a single statement. Alright, so let's write out our value for y. Console.write line while, nope, this is a do loop, so do, and then we're going to pass in y as our placeholder, and then y minus minus. Then I'm going to add some comments. This is the end of main. This is the end of the class. And then the last one's the end of the namespace. Just to keep track of things. So these should do, if I have predicted correctly, the exact same things. And I'm going to run it without debugging so it'll keep the screen up, but then I'll probably add just a read key to the end of it. So start without debugging. Whoa, I did something wrong. Oh, this is brilliant. I really meant to type y minus minus there, but I typed x minus minus. The first loop is iterating x, so it needed x minus minus. The second loop is iterating y, so it needed y minus minus. And I'm going to go ahead and put my console.read key at the very end. And just make a comment that that pauses it. Alright, so it counted down 10 to 1, 10 to 1. What's the big deal? The big deal is that a do loop has to execute the body of the code at least one time, whereas a while loop doesn't. So what you could do with a do loop is do a whole bunch of processing and then ask them if they wish to repeat or not, and then put that repeat condition down here at the bottom. And that can save you a little bit, but honestly there's nothing you can do with a while loop that you can't do with, no, I'll reverse that. There's nothing you can do with a do loop that you can't do with a while loop. So where these differ is, what if I change this to -10? It wouldn't print anything. because x is not greater than 0. But if I change this one to -10, the y to -10, then it's still going to print it out once. It's going to print out -10. Then it's going to bail out of the loop. All right, I think that's enough about do loops. I don't use them very often. Not all languages support them. Python doesn't, for example. And then nested loops. Nested loops are when you have a loop inside of a loop. I'm going to declare two variables, A and B. I'm going to set them both equal to 0. And then I'm going to have an outer loop, which counts A. So while A is less than 3, now let's start them off at 1. So A equals 1, B is equal to 1, while while A is less than or equal to 3, that's the ending of that loop, beginning of that loop. While B is less than or equal to 3, tell you what would be fun. On this line here, before that second while, set B equal to A. And then inside this, we're going to print console.writeLine A equals placeholder 0, B equals placeholder 0, comma A, comma B. And we need to have incrementers for each one. So in the inner loop, our loop control variable is B, so we're going to do B++. And I'm going to put a comment here, end inner loop. And then before the end of our outer loop, we need to increment A, because that's the loop control variable for the outer loop. So what is this going to print? It's going to print, see, B gets iterated every single time, all the way through its sequence before A gets incremented once. So it's going to print 1, 1, 1, 2, 1, 3, because B is going from 1 to 3. Then it's going to start over. A is going to be incremented, so A will equal 2. And then it would have printed 2, 1, 2, 2, 2, 3, but we set B equal to A. So it's just going to start counting at 2. And then when we go back up here, A is going to equal 3. We're going to set B equal to 3, and so this inner loop is only going to execute once. First time it executes, it goes from 1 to 3. The second time it executes, it goes from 2 to 3. The third time, it just goes from 3 to 3, which is one time. Maybe that makes sense. Or on the other hand, it could just hang. What did I do wrong? Oh, I put my read key in the wrong place. Read key goes at the bottom of the program. Excuse me. I'm moving that read key down to right before end main. So here's my nested while loop, right there. Last time we used a nested loop to print out a rectangle, right? Our first counter was the number of rows, and the second number was the column counter. And so here we go. Not what I expected at all. I thought B was going to go 1, 2, 3, and then when it got to 2, it printed 2, and then when it got to 3, it just printed 3. Not quite doing what I wanted. What is it doing wrong?
Is it because we have the 0, 0 in both places?
Oh yeah, look at that. I was printing out the same value twice. I was printing A 2 different times due to my placeholder error. So I need to fix this line. I had 0, 0 inside the placeholders. Got to change it to 0, 1. All right, now it looks right. 1, 1, 1, 2, 1, 3. Then A clicks over. And then B started off at the value of A. So 2, 2, 2, 3. and then A clicks over one more time, and B started at that value, so it just prints 3, 3. You could print a triangle like that. You know, the first line would be 3 stars, the next time would be 2 stars, the third one would be 1, something like that. But I think that's a good enough demonstration. What with the rectangle we've already done, and now the sequential counting. What's it going to look like if I comment that line out, where we're not setting B equal to A?
Aren't they already equal? Well, it's just going to say 1, 1. They're just going to be equal the whole way down.
Right, it's going to do 1, 1, 1, 2, 1, 3. Then it's going to do 2, 1, 2, 2, 2, 3. And then it's going to do 3, 1, 3, 2, 3, 3. Let's add an extra right after we increment A. Console.WriteLine A incremented. And then let's change our right line here to say B incremented. I don't know if that's the right place to put it. I'm going to undo that. I'm going to leave it alone. We're not going to print out when B is incremented. We're just going to know that every time we print out A is equal to 0, B is equal to 0, B is being incremented. So now, I've broken it again. I never reset the value of B, so that's a problem. I'm going to uncomment that. Go back to our original. I should have set it equal to 0 if I wanted to rerun the experiment and have it look the way it did. So, A is the outer loop. So B has to go through all of its iterations before A gets incremented. Whoopsie. And then once A does get incremented, then B goes all the way through its loop again, but it started out at 2. And then we increment A one more, the outer loop, and so it has to go through all of the iterations one more time. That makes sense? Something looked weird. I'm not sure what. Okay. So that's do loops, that's nested loops. I bet you've already hit the concepts of nested loops in other classes. Do loops will be new to you if you haven't taken Java or C++. And I didn't mean to launch NetBeans. So the loops don't quote overlap. In our output here, we're never incrementing A and B at the same time. We run all the way through the inner loop before A gets incremented. Then we run all the way through the inner loop before A gets incremented, and so on. So it's a strange thing to say that they don't overlap, but you just don't get both of them being incremented at the same time, unless you're doing something really weird. Pictorial representation. Here's our loop here. We go into it. The inner loop repeats a whole bunch of times until we go back out to the outer loop again. Then if this is still true, keep doing that. So accumulating totals. The easiest kind of conceptual algorithm. You want to add all the numbers between 1 and 10. You want to multiply all the values between 1 and 5. You want to add all the prices that the user enters. So totals are accumulated. What you have to do is you have to have a sum variable, an accumulator, and then inside the body of your loop you start adding to the accumulator. Then it starts talking about garbage. And garbage is an unknown value. The C# compiler helps to prevent seeing an incorrect total by requiring you to provide a starting value. C# will not use the garbage value. This is just saying that until you initialize a variable, you can't use it. And we already know that, so I don't quite know why we're talking about it in this context. But we could prove that. I mean, for funsies, let's go write a sum loop based on our while loop. So let's go here, right before our console.read. Okay, we're going to write another very simple while loop. But we're going to need a counter, which I'm going to make x. That's our counter. And we're going to need a sum, or total. I like actually making the sum a floating point so that later on if we calculate average. Oops, we already have x. We can't use x as our counter. Okay, how about c? Or I? All right, I is going to be our counter. Is it still complaining about that? I have I used already? Okay. Maybe the underline will go away. So I'm going to store my total in a variable called sum. Now I'm going to write the loop. While the counter is less than or equal to 10, sum plus equals, and I forgot something, c. Okay, now I'll show you what C wizards tend to do. Here's what we would normally have to do. We'd have to put this stuff in braces, and we would have to increment the C counter like that. Some programmers are awfully fond of doing it like this. And we're getting an error here because sum hasn't been initialized yet, and we knew that would be a problem. But some C++ programmers like to increment on the spot, like that. And that's actually legal. What this says is take C, add it onto sum, and then increment C. And it would work. Do I like doing it like that? I think that's a little too clever by half, but once you get used to seeing it, it does make sense. I'm going to go back to the way it was. I'm just going to put the brace here, the brace underneath it, and increment C, C++. And lo and behold, the code's not going to run. There are build errors. Okay, we've proven that you have to initialize sum before you could, right? That made sense before we hit that slide.
If you declare all your variables at the top, is it just a good idea to just go ahead and initialize all of them?
Pretty much I initialize every variable as I create it. The question is it a good idea to initialize your variables up at the top as you create them? And I say, yeah, it's a good idea, but on the other hand, if you're using the Java editor NetBeans, it flags all those and says initialized variable or value ignored. It treats it like it's a serious problem that you're initializing them to values that are later going to be reset to something else. But I like doing it. There's nothing wrong with setting them all equal to 0, just so that when you want to use them later, they're already set. So that brings up the point. You could be moving all these variable declarations up to the top. And I'm of two minds. I like seeing variable declarations up at the top, but on the other hand, I also like seeing them near the code that actually uses them. So, we could take this sum is equal to 0 and C is equal to 0 and where we initialize A and B and stuff like that and move it all up to the top. But I like seeing it right next to the code that's going to do it. Okay, so this is a summation loop. If you wanted to calculate the average, it's just a sum divided by the number of iterations, which we should not have hard-coded, right? It ought to be in a constant or something like that. But doing it the easiest way possible, double average is equal to the sum divided by 10, because 10 is our counter there, or our maximum value. We could get away with using C as our quantity there, but I wouldn't do that. And then we could just print them both out. System.out, what? Excuse me, console.writeLine summation 1 to 10 is placeholder 0. And let's print out the sum. And then console.writeLine average is placeholder 0, comma, average.
Could you not, with the average not be the sum divided by C?
In this case, sum will equal C. So that'd be a perfectly good way to do it. The question was, could we do sum divided by C? Why is this still giving me an underline? I guess it doesn't, since I haven't saved it, it doesn't know that sum is now initialized. Anyways, this would work because, no, it wouldn't. The reason why is because since I did less than or equal to 10 rather than less than 10, by the time it escapes this loop, C is actually equal to 11.
Right, okay.
So, wouldn't want to do that. Would want to do this. We could keep track of another counter. Double, count, or not even double, I'm not saying that we're going to have to do this. I'll probably delete it later. But every time we add one onto C, we add one onto our counter as well, and then we could delete by our counter. That's slightly better. It's complaining here. Oh, because I called it count. Excuse me, counter. The real way I'd like to do it was to declare this as a variable and just use that in both places. But this isn't bad. Not a bad way to do it. For one thing, what if you had a loop where you had an indeterminate number that you were going through? You didn't know whether the user was going to enter 1 or 100 values. Okay, so I kind of like that. But this was, yeah, I'll just leave it at that. This is a pretty good summation loop. A for loop would make it look a lot easier. Don't recall if we've hit for loops yet. My hunch is not. Usually they're introduced after do loops. So that's a summation. The way you do it is initialize your accumulator variable, and then you do your while based on your loop variable, based on loop control variable, counter, and then you add to your accumulator as required, and then you update your counter. If you're doing it that way, if you're doing it with a counter. If you're not doing it with a counter, if you're adding scores that you input on the fly, then the while is going to be based on something. So I'm just going to change this to while condition, and then here I'm going to say update condition. And I can't type apparently. Accumulator. All right, there we go. That's your general loop processing when you're adding a total. We could ask the user for a series of scores and add them up that way as well. And I swear we probably have already done that in this class. Have we written a program? My brain gets confused between Java and C#.
Have a great program that does what?
You input a series of scores
And he gives you the
or
average.
random numbers and it gives you the total and the average.
Yeah.
Okay. I think we've done enough of that. We know how to calculate totals by this point. So C# will not use a garbage value that happens to be stored in an uninitialized memory location. There are times, actually, when you really could hit a value that was uninitialized, but not just in a locally declared uninitialized variable. Here's an example of using a total with a slightly different while condition. While purchase not equals quit. So enter next amount or quit to quit. We read that line in, we get that data, and we add it to the total. Notice that this is one of those that requires a priming read. My least favorite kind of loop. We ask them for the purchase amount, we get that purchase amount, we convert it to a value, and then inside the loop we add it to the total and we ask them for the next purchase amount. So that's the first part, your priming read. Least favorite way, but it works. I'd rather do it with a break statement. So make sure the loop avoids unnecessary operations. Consider the order of evaluation for short circuit operators. Employ loop fusion. Use prefix incrementing rather than postfix incrementing. Improving loop performance. Let's read about that. Avoid unnecessary operations. A loop should execute while x is less than the sum of two integers a and b, and neither a nor b is altered in the loop body. Could be written as while x... Okay, I see what they're saying here. This is a fine condition, while x is less than a or b, but you're having to calculate a plus b every single iteration. If a and b are not going to change in the loop body, just do this. Calculate the sum of a plus b beforehand and base it while x is less than sum, so that it doesn't have to do that math every single time. On the other hand, if a and b are going to change during the middle of the loop, you couldn't do it that way. So in the code on the left, it executes 1,000 times. So a plus b is calculated 1,000 times. On the code on the right, the results are exactly the same, but this a plus b only happens once. So you could have considerable performance gains by avoiding unnecessary operations. In other words, your while loop should be as simple as you can make it. If you can avoid additions or function calls or stuff like that in there, if you could predetermine your maximum value before you get into it, the better you are. Consider the order of evaluation of short circuit operators. If you use and or, I don't recall talking about short circuiting. I'm pretty sure that we've done this in other classes. I don't remember talking about this in this class. If you have and or, if A is equal to 3 and B is equal to 2. If the first part is false, do we even have to check the second one?
No.
And the answer is no. You don't have to check the second one because and requires both sides to be true. So if the first one is false, so for and, if the first value is false, the second value is skipped. The second evaluation is skipped. And you could say if the left-hand side and the right-hand side, but whatever, you get the idea. What if it was ors? If A is equal to 3 or B is equal to 2. Let's try the same idea. If this is false, do we still have to check the second one? If this is not true, if A is not equal to 3,
then it's not going to run.
then
Right?
do we still have to perform this check?
No.
Actually, we do, because or means either one side or the other. So the fact that this is false doesn't mean that that one, right?
Thinking it was and.
Yeah, so that would be true for and. So, but if this is true, if A is equal to 3, do we have to evaluate B is equal to 2? And the answer is no, because or means either one side or the other. So if we've proven the first side is true, we don't even need to do the second one. So for or, if the first value, first evaluation, is true, the second one is skipped. That skipping is known as short circuiting. And that's done for performance reasons. The compiler figures out that if this part isn't true, it doesn't even need to check that. And for ors, if this first one, I worded that false, oppositely. Anyways, if this first one is false, it doesn't need to check the second one for ands. If the first one is true, it doesn't need to check the second one for falses. And if this loop repeated 5,000 times, and that wasn't the case, then you're going to be comparing that, calculating that 5,000 times and that 5,000 times. You could diminish the number of times that this calculation was done dramatically by short circuiting. You don't have to do anything special to get short circuiting to happen. The compiler provides the code to do it. On the other hand, the slide seems to be implying that we need to design our code to do short circuiting. So let's look. Remember that the expressions in each part of and or use short circuit evaluation. When a loop executes many times, it becomes increasingly important to consider the number of evaluations that take place. Ah, I get it. If you believe the first Boolean expression is more likely to be true than the second one, you can eliminate this testing of the second one on more occasions. That seems backwards to me. To me, if this is going to be true an awful lot, but this is only going to be true a few times, I'd put that one first, so that you could rule out the vast majority of times, and you could only do it when that one was true. On the other hand, for ORs, it makes sense to put the one that's less commonly true at the beginning. No, I think it's true for... I don't know if I quite agree with their statement. I'm not going to think about it much more than that. Maybe the slide next to this. Alrighty. So if you believe the first Boolean expression is more likely to be true than the second one, you can eliminate testing the second one on more occasions. I think it ought to be reversed because I think this is only true for ands. I'm not going to take the time to figure it out. Loop fusion is a technique of combining two loops into one. If you have a for loop here and you have a for loop here, apparently we have talked about for loops. And if you're repeating the loop the same number of times, we're going to increment x from 0 up to 20. And you're going to call method 1, and then you're going to increment x from 0 to 20, and you're going to call method 2. Just fuse them. Write one loop that'll do two things. So yeah, the term loop fusion sounds like a really cool concept. This just means putting as many activities in a single loop as you can, rather than break them out into a whole sequential bunch of stuff. Now sometimes you have to, do them in order. Maybe you're building an array with the first loop, and then on the second loop you're processing the array or something. Maybe you can't combine them. Maybe you have to have the entire array built before you can do the processing. But in this example here, you have the same loop condition, identical loop condition, and you're calling one method, and then in the same kind of loop you're calling method 2. You just put both methods in the same loop. And use prefix incrementing rather than postfix incrementing. This is saying that we ought to change x++ to ++x. Because incrementing x is a standalone statement, the result is identical whether you use one of these. But, and it doesn't say why, ++x is faster than x++. I'm just going to have to take that on faith because I've seen that mentioned more than once, but I've never figured out why. Timing compared to loops.
Yeah, I told you about this, remember?
Yeah.
Stopwatch and stuff.
Right, so you write a loop that does a stopwatch, and it uses ++x, it uses a prefix, and it ran at 45 milliseconds to do 1,000,000 loops. And then if you put the increment after it, it took 49 seconds. So you did get some time savings by doing ++x rather than x++. I don't know if I'm going to be able to break myself of the habit of putting the postfix, but I'll give it a shot. All right, and in our lecture we just got some giggles over the fact that we saved a whole 4 milliseconds, which is 4 1,000ths of a second, over 1,000,000 iterations of the loop. So is the savings that incredible? I don't know. But I suppose if you were writing the absolute fastest code possible, I question why you would be using C# at all. But you could do that. So looping issues in GUI programs. Using a loop within a method in a GUI application is no different than using one elsewhere. So we could add a button to our form, and then when you click that button, it would run in a loop. Event-driven programs sometimes require fewer coded loops because some events are determined by the user's action. You can write an event-driven program so that an action continues as long as the user continues to take the appropriate selection. I'm going to just leave you that as something to ponder yourself rather than try to explain it. Here we go. The greetings form, when it starts and after the user enters a number. So how many greetings do you want? You type in 5, you press click, and then inside the button handler, it has a loop that prints out the greetings that many times. I'm not seeing how that's any different than any other programming.
I think it popped just to be annoying. That'd be great.
Yeah. The bank balance form, when it starts and the user has clicked yes 3 times. Do you wish to see your balance? Yes. It prints something. Then you click, do you wish to see your balance? Yes. It prints something else.
What?
Well, it is event-driven. You know, it's responding to each time we click yes. But we're not really looping at that point. The user's doing the looping. Yeah, so the user is clicking yes as many times as they want to, and then finally when they click no or they click X, it kills the program.
But their balance is going up. I wish my balance would go up every time I check my account.
Yeah, I wish my balance would go up like that, but they do have some code that's incrementing the balance. Every time you click yes, it goes and it adds to your bank balance by the interest rate. So you're providing the impetus of when to stop, rather than it being a fixed loop. So you're not actually writing a loop at all. The user is doing all the looping. It's a weird way to think about it. So our summary, you use a while loop to execute a body of statements continuously while some condition continues to be true. You use a for loop when you're going over a definite series of values, when you can determine the starting value, when you can determine the test, and you can determine the expression that alters. As I've said, you can always write a for loop as a while loop, and if you go insane, you can always write a while loop as a for loop. I would word these a little bit differently, and I think I have done so in the past. So the do loop checks at the bottom of the loop because it's a postfix, post-test loop. You can nest any combinations of loops. You can put whiles inside of fors, inside of do's. In computer programs, totals are frequently accumulated. You can use loop performance by improve it by making sure the loop does not include unnecessary operations. And you can use while, for, and do in the same ways in console as in GUI programs. I mean, pretty much. I can't see when you would be able to do something in a console program that you could not do in a graphical program. That'd just be weird. It's not like you ever see console programs anymore. They're all GUI, right? Okay, so when to use the loops, regardless of what they say. You use a for loop if you are iterating through a predetermined series of values. Whether it's a series of numbers or an array, whether it's a list, if you know that you're going to have your numbers all defined in advance, whether it's a range of numbers or a range in a list, you use a for loop because the syntax is the cleanest. So all of our counters that said while x is less than 10 or whatever, I should have written them as for loops. Then use a do loop if the body has to be executed at least once. And then lastly, use a while loop otherwise. That's how other textbooks have stated it, and I think that that's a pretty good determination. And since my mind doesn't think in terms of do loops, I usually either use for loops or while loops because there's no logic that you can't do with the do loop there's nothing you can do in a do loop that you cannot do with a while. But
I feel like maybe a do loop is good for like a menu.
yeah, do loops are good for menu-based programs where you're going to offer the user a choice. Actually, what they do, though, is where you perform the choice and then you offer them the next thing they're going to do. And you can still do that just as easily as with a while. So your logic is while, or let's try to write it as a do. While do,
Oh, don't let me think of me.
continue is equal to true. No, 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 you don't put that up there at the top. All right, so do, you print your menu, you get your choice. If the choice is wrong, if they haven't chosen quit, you set continue equal to false. Else, you actually do the code.
That's why I was saying maybe that's good for a menu, because you're gonna want a menu presented at least once. So.
Yeah, and so our do case would be while, do this while continue is equal to true, which requires us to have this up here. Continue is equal to true. Can I type? Can I type? Continue is equal to true. That's how you could do that with a do loop. To me, that looks remarkably the same as you would do it with a while loop. And the book probably actually shows a good example. But if you change this, while continue is equal to true, and you took off the final condition, there's going to be no difference between the way it functions. So what I would do is this, while true, and then if the choice is to quit, I would just break. Save ourselves having to define a control variable and then update it.
Can't you do that with the do loop too? Can't you just break?
Yeah, you could break out of a do loop.
No, wrong thing. Okay.
In which case it looks like this. Do some stuff while true.
But then that wouldn't make any sense to do that when you get to the while true. Okay, makes sense.
But it's the exact same logic either way. So we're done with chapter 5, but I want to go back and play with the idea of chapter 4 just a little bit more, which is the if statements. And yeah, we know how to use if statements, but what I really want to hit is the idea of random numbers. So there's a class called random, as there is in many frameworks, that'll generate random numbers. So random R&D is equal to new random. That creates our random number generator. Now let's get a random number between 1 and 6. Dice have 6 sides. You roll a die. It's going to be between 1 and 6. So int d1 is equal to rnd.next. Not next int if you're thinking in Java. Starting at 1 and going up to but not including 7. So that's a value between 1 and 6. And then you could get int d2 is equal to the same thing. I should just copy this. Int d3 is equal to that entire line as well. So I'm just going to copy it and paste it. And so now I'm going to declare total. Int total is equal to d1 plus d2 plus d3.
Why is it 1 through 7 and not like 1 through 6 again?
Yeah, why is it 1 through 7 and not 1 through 6? Very good question. They could have written it very easily so that this was an inclusive upper bounds rather than an non-inclusive upper bounds. I don't really have a good answer for that because I've seen some libraries where you do specify the upper bound. So you always just have to go and hit the documentation when you use a random number generator to figure out whether it's going up to and including that one or whether it's not. And like it's clicking around in my brain that maybe in Python the upper end is inclusive and in Java it's not, but can't say that for sure. Okay, so we have a die roll there. Or we've rolled 3 dice. So there's a game called Risk. where you're trying to take over the world and you're moving armies all over the world. And when you're attacking an army or attacking another country, you roll 3 dice, your opponent rolls 2 dice, and you determine the winner by adding up those numbers. You know what? I'm going to pause this and research that before I say something stupid. All right, guys, I looked up the rules for Risk. I don't feel like actually implementing it, so that'll be a later something or other. Let's just compare the results of 2 D3 rolls. So now that we've got a total, I'm going to call it total 1. We've rolled 3 dice. We've added them together. Now, let's roll 3 more dice. We could declare D4, D5, and D6, or we could just repeat these. D1 is equal to R and D, next, 1, 7. D2 is equal to the same thing, so I'm going to cheat and copy paste. Changing D1 to D2. Cheat and copy paste, changing D2 to D3. There we go. And I'm going to make a total 2 now. Int total 2 is equal to D1 plus D2 plus D3. So now, at this point, total is between 3 and 18, but it's a bell curve. So the most common numbers rolled are going to be 9, 10, 11, 12, like we care. Here, this total is also going to be between 3 and 18. Let's find out which is larger. Let's just print, use some ifs, if-elses. First, let's find out if they're the same. If total 1 is equal to total 2, then cout, that's C++, console.writeLine. We ought to print the rolls. They match. Else, if total 1 is less than total 2, then let's write out console.writeLine total 2 is higher. And if neither one of those cases is true, that meant that total 1 was higher. And it would be really neat to loop this. Repeat this 20 times in a row. So to do that, just for variety's sake, who wants variety's sake? Yeah. Let's do, I typed in do. Apparently I really want to do a do loop. I'm going to call this turns. This is going to be our first turn. And while our turns is less than or equal to 20, we're going to go 20 turns in a row. So since I didn't do all that to begin with, I'm going to need to be really careful about my indentation. All this stuff about D1, D2, and D3, and totals and the if statements, all of that needs to be shifted over. And it'd be easier to see all this if I removed my braces there and there, so that all of the code fit just about on one page.
So even the declaration of our dice needs to be in that loop.
Well, we could take the declarations out. We could just do this, int D1, D2, D3, and then we could do this. And there might be some slight performance gain from not having to, reallocate the memory for that variable. I can't say for certain that that's true. Okay, so that's the entirety of our code right there, except there's one more brace underneath it all. Except I haven't incremented turns yet. And we didn't print out total 1 and total 2. That would all be useful information. So above our block of if statements, let's print out total 1 and total 2. Console.writeLine, total 1 equals placeholder 0, total 2 equals placeholder 1, comma, total 1, comma, total 2.
It says embedded statement cannot be a declaration or labeled statement. So does that mean that you have to define them out of the loop?
No, it would have worked just fine if I'd had that, if I had declared the variables in a loop. So I'm going to have to come back and look at yours. And let's also print out what turn it is. So I'm going to have to change my placeholders, or I'll just tack it on at the end. Total 1 is equal to that, or total 0, total 1, total 1 is equal to placeholder 0, total 2 is equal to placeholder 1, turn is equal to placeholder 2, and I've got so much here that I'm going to break this print across two statements, total 1, comma, total 2, comma, turn. Excuse me, turns, because that's what I put up here as the name of my control variable. All right, in a last-ditch effort to get all this to fit on one page of screen, I'm going to put the results of the ifs on the same line as the ifs themselves. And then at the last, I'm going to do turns plus plus. Now I need to make sure. Okay, going down to the bottom. All right, so here is our code. You have to make sure that you have the random object declared above this. Random R&D is equal to new random, parentheses in parentheses. So you have to have this statement above here. You also have to declare your turns. I think I'm going to put that on the same line of ints. You don't have to do this. I'm trying to get everything on one line. So I'm going to put turns is equal to 1, comma, and then D1, D2, D3. And we're so close to getting it all on one line. Or one page. The only way I could do that is if I move the brace up for the while like that. That did it. But I haven't tested it. Let's test it. Okay, it ran for 20 turns. Total 1 was higher, total 2 was higher, total 1 was higher, total 2 was higher. We could put some additional if statements in there that would increment counters for how many times total 1 was higher and how many times total 2 was higher. In which case my efforts at getting it all to fit on one screen would be completely of no avail, right? Because I'd have to use more than one statement in these ifs. I'd have to use blocks of code. Alrighty, I'm going to pause the recording now so I can go check what the students are doing.
I fixed mine.
So for the homework, based on this concept, I think what I want to do is have you write a program, ask the user how many turns to go. Each turn total 1 should be D1 plus D2, where D1 and D2 equal random values between 1 and 6. Total 2 is equal to D3, where D3 equals a random value between 2 and 12. So what is this doing? This is generating a number between 2 and 12. This will also be a number between 2 and 12. And these are all inclusive. But remember, your random number is going to have to go up to 7 for these and up to 13 for that one. Just, for your random function call, for your .next call. So what is the difference between this random number and this random number?
Difference between,
Is there a difference in how these, there's a difference in how they're calculated, but in the end, is there a difference in the results? And the answer is yes, because if you're adding two values, you're going to generate a bell curve. Like if you roll two numbers, 7 is going to be the most commonly rolled, and 2 and 12 are going to be the least commonly rolled. So here, this is a bell curve where 7 is the most, and the ends of it, 2 and 12, are the least, for reasons I'm not going to go into, statistics. Whereas this one is just a linear 2 to 12.
okay, explain the top one more time. It's random values between 1 and 6, so the greatest value there could be is 12. And okay, never mind, I get it now.
Right, so if you have,
You're not gonna roll sometimes, or you're not gonna roll.
yeah, here's all your choices. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And this would actually take me a little bit of time to type out. Or if you rolled a 2 as your first die, or you rolled a 3 as your first die, or you rolled a 4 as your first die. How many times could you roll a 2? Only once out of 36. So one time out of 36, you roll a 2. How many times could these add up to 12? One time out of 12. Now, I didn't fill in the middle, but we'd find out that the most common combination would be 7. So total 1 is going to be a table like that, whereas total 2 is just going to be a 1 or a 2 or, excuse me, a 2 or 3 or 4 or 5 or 6 or 7 or an 8 or a 9 or a 10 or 11 or a 12. And it's going to be the equal chance of any one of these rather than having a minimal chance of getting a 2 or a 12. It'd be fun to write a program that would generate the bell curve for Paradise. And maybe we'll come up with a way of doing that. Okay, anyways, you ask for the number of turns. You generate your random numbers. If total 1 is equal to total 2, add 1 to the equals counter. If total 1 is less than total 2, add 1 to the T2 wins counter. If total 1 is greater than total 2, add 1 to the T1 wins counter. Total 1, 1. So this would be inside your loop. Inside your loop for each turn, you're going to do this stuff. Calculate total 1, total 2. You're going to have your block of if statements. If the total is that, if the total is that, or if the total is that. We're going to obviously need these counters declared up at the top. So ask the user how many times to go. Initialize 3 counters equals T1 wins and T2 wins to 0. Inside your loop, you're going to do this stuff. After your loop, you're going to print out, display, T1 wins, T2 wins, and equals. My guesses are going to be about the same number of wins, because even though one is bell-shaped and the other's not, they ought to be, That's my hunch, but I don't know for sure. So it'd be interesting to see. So I'll rewrite this in a prettier form, but does that make sense?
Yep.
Do I get a nod from?
Yeah.
All right.
Yep.
Okay. All right, so that'll be the homework. We will make that.
It usually does. Sorry, I'm trying to take a screenshot of my stuff. Do a lot of that.
That'll be homework 6. Which is going to require a loop. And if else, if else. Maybe there's another way to do it.
Zero counts as an unsigned integer, right? Is 0 an integer?
Yeah, 0 counts as an integer, at least in computerese. If you assign an int 0, that's great, but if you assign an int 0.0, the compiler will reject it in most languages, not in C++, where those conversions all happen automatically. All right, so this would be due, if this was the daily assignment, we'd make it due Sunday, but since it's not the daily assignment, we'll make it due the following Sunday, which is too much time, but that's okay. So we have an exam coming up. We've gone through chapters 1 through 5. I need to post the quizzes because so far we've only had a quiz over chapter 2. So I need to post the quizzes for chapters, wow, not for 3. 3 was the graphical user interfaces, right? So I'm going to skip quiz over chapter 3. The questions would be very minimal. You know, what is a button? What is a text box? That kind of stuff. And so we're going to have a quiz over chapters 4 and over 5. And then our quiz is coming up. I saw our date. It's actually fairly late in the semester.
The 13th, 14th.
Yeah, the 13th and the 14th. That weekend. I might open it up a little bit earlier than that, but you know, like on maybe Thursday through Sunday, you know, 12th, 13th, 14th, 15th. That'll give you plenty of time to get the quizzes done and for you to see your answers, see what you missed. Retake the quiz if you want to boost your grade up a little bit. So let's post a notice about that. September 27. We did a lecture over loops, finishing chapter 5. We are now done with unit 1.
Is a decimal bigger than a double?
I bet they're the same size, but that's a good question. The question is a decimal larger than a double? Google up C# double decimal bytes and see if you can get a count of how many bytes each one takes. A double should be a 4-byte data type, and I would bet that a decimal is 2, but I can't guarantee it.
So the decimal's a lot slower because it's 16 bytes.
16 bytes for a decimal?
Yeah.
It's 4 times larger than a double. Okay. Our exam will be available for taking from Thursday the 5th to Sunday the 13th. Wait, that's not right. Not Thursday the 5th. Thursday the 12th to Sunday the 15th. This evening, I will upload these quizzes for chapters 4 and 5. I have plenty of time to take the quizzes. see what you missed and redo them if you want a higher score on them. What will the exam be? Very similar to the quizzes. Plus a little bit of code writing. And when I say a little bit, I'm not going to ask you to do a WIN form or a WPF form. It's just going to be all console application or just pure code. I may give you a chunk of code and ask you to expand upon it. You can probably, yeah, anyways, that's enough.